Hey, good afternoon and welcome to MetalCon Live. It's great to have you with us today. I'm Judy Geller, Director of MetalCon, here with Kaylin Burke, who is running the controls. Today, we bring you rail-less solar on metal roofs, presented by Shelley Higgins, Architectural and National Accounts Director at S5, and Mark Geis, Director of Solar Business, also from S5. S5 is also the sponsor of a new Solar Center exhibit pavilion we're offering at MetalCon 2021 this year. And this is where leading brands in solar components, performance monitoring systems, smart energy, and other solar solutions will be showcasing their products. If you'd like more information about the pavilion, you can send an email to us at info@metalcon.com for details. Something else I'd like to share with you that's new to MetalCon this year is the exclusive Architects Experience. It's really designed to be a show within a show for architects, designers, specifiers, and engineers who are ready to breathe new life into projects and solve a wide variety of architectural, structural, environmental, and building performance challenges, all through the use of metal. In other news, all 10 courses of the popular Metal Focus Safety Program are now available via demand on metalcon.com. And be sure to mark your calendar for the next MetalCon Live, which will take place on June 2nd. The title is Increasing Staff Production Through Summer Production. It's part of the MBA series presented in partnership with Danny Kerr's Breakthrough Academy. So that'll be great. Danny is an amazing presenter. Finally, if you haven't been on the MetalCon website lately, we hope you'll check back soon to see all we've added about workshops, pavilions, the exhibitors, education, all the credits you can earn. There's so much there. And especially we'd like you to notice that registration and housing are both open. And we are looking forward to getting the industry back safely together in Tampa next October, and we sure hope to see you there. During this webinar, if you need technical support, reach out to MetalCon support in the chat box, and don't forget to complete the post-webinar survey to earn AIA HSW LUs for today's session. And now I'm going to turn things over to Shelley and Mark.
Thank you, Judy.
You're welcome.
So I was going to reiterate the architectural experience at MetalCon is going to be a real good surprise for us all. Oops, hold on. I need to, there we go. Mark, can you take it back to the next one? The architect's experience, I just wanted to mention to any of the architects that are with us today, we are going to be featuring the legendary architect Jan Weymouth, and we are going to tour his Dali Museum. So I just wanted to let you know that is one of the plans for the MetalCon show this year, and hope you'll join us there. Next. So our course today is Rail-less Solar on Metal Roofs, Wire Management and Best Practices. The presenters are Mark Geis, Director of Solar Business, and myself, Shelley Higgins, Architectural and National Accounts Director. This course is sponsored by S5. The course number for AIA is MRIL 2142. It is also NABCEP approved, and you can get a credit in 1.5 hour credits, JTA and RE electives. This course is copyrighted. You cannot reproduce or do anything without our permission. So, and our provider number for the AIA is 401-07851. Next. Next. So as you know, if you are in with AIA, you must complete the whole course in order to receive credit.
Oops.
Go ahead. This is a live structured instructor-led course, And again, 1 AIA HSW credit and 1.5 JTA and RE electives if you're NABCEP approved. I will be sending out certificates by email. And if you have registered with your AIA number, I will be reporting those directly to AIA. So our course description, as solar mounting technologies evolve to improve installation efficiencies and reduce material and labor costs, some developers and installers on the job site often find it daunting to keep abreast of changing technologies and adapt their operating procedures accordingly. And this seems evident by phobias some people have about rail-less PV mounting for metal roofs, while many others claim it is a piece of cake and they save a fortune. A few small shifts in thinking can produce huge savings in labor, material, and logistics, so it's worth taking a look. The shifts pertain to the mechanics of installation and a couple of other aspects of a project, such as wire management. And this course unpacks metal roof installations with a brief overview of the various types of metal roofs and their advantages for PV. Wire management techniques are presented in detail, along with other best practices and how-tos for installing rail-less solar systems on metal roofs. Finally, methods for installing various accessories from microinverters to home runs are discussed. Next. So our learning objectives, upon completing this course today, you will learn why metal roof is a perfect solar platform, define the advantages of rail-less solar PV mounting systems, understand how solar on metal roofs prove to be the most economical and the most eco-friendly, learn best practices for design and deployment of wire management, describe best practices for installation techniques and other balance of system requirements, components. And our focus here will address these major concerns: your PV system design, your wire management, what are the specific installation techniques, and module level power electronics. So the challenges that we're facing with the ECPs and the installer space are the evolving technologies. They change so quickly, and once you've learned something and having to learn it again, when you've got the guys out in the field, this can be, you've got labor saving. If you learn them and you're using them, they can produce material and labor savings. But you have those learning curves, you have the installation teams that are well trained, and then pulling them back out of the system to learn, it slows them down, and it may not, but we want you to encourage you to do these things, because overall, when you change and learn, reset the learning curve, it can take time to do this, but then it actually will end up speeding up and making it more advantageous for you. So this is the course layout. Some of these things we're going to go over briefly. Some of them we're going to do a deep dive into. So if you are wanting to learn more about something here that we don't address, enough, we have these courses available, and you'll be able to sign up to take something at a later date. And I'm going to, oh no, this is me yet, I'm sorry. Brief history on metal roofing. So metal roofing is not a new thing. It's been around for a very, very long time. So we look here, you could see some of these buildings have been around for many, many years. They're iconic structures like Dome of the Rock, St. Marco's Cathedral, the Blue Mosque, and the Notre Dame. If you notice, they've all got metal roofs, and they've been around for a very, very long time. So here we're gonna take it off. This is you, right, Mark?
No.
No, this is me. I'm sorry. I'm like ready to jump the gun here. Durability and sustainability. So when you look at a standing seam metal roof, it has a service life 60 to 70 plus years, depending on your environment and the environmental severity. And it's the most highly recycled construction material available. And you really want to think about these things because that's going to affect your solar system. And you have to think of this as your foundation or your basis. It's part of your solar system. Whatever you're mounting it to becomes a part of it. And with the steel roofs, the metal roofs, the standing seam metal roofs especially, they last a very long time, and they last longer than the solar system themselves. And those are all things that you need to take into consideration. So there are metal roofs out there that have been around for more than 200 years. And remember, the roofing is 100% recyclable, and it just makes economical sense. But last but not least, it costs less to install on metal roofs. And Mark's going to go into that.
Okay, so I'm taking over. So first of all, thanks, Judy and Kaylin, for allowing us to speak. And thanks, Shelley. So I'm going to get into really the differences. What is a railless system versus a rail-based system to start off with? So I'm going to do it with pictures. So here's a rail-based system. PV, this is solar PV on a metal roof with rails. So the picture on the left is actually of the rails that are being put on ahead of time. So those are there. And then the solar panels are installed on top of those. Those red dashed lines are the rails underneath. And they're placed in a way where they support the module where the manufacturer recommends they're supported. One thing that I think is interesting, I always like to take pictures of, like, here's it with the rails, and now here's the final picture. And actually, it's very applicable to what we're talking about today, because if I look at the first picture, that's really an entire project. So there's a lot of time being spent putting those rails up before you even put a single solar panel on. So you have to snap lines, you have to measure, you have to attach all those, put the rails up, and then you go down and then you start your real installation. And with a railless system, you really don't have that first part of the installation process. This is a steep slope residential. Another thing you'll notice is that the rails go perpendicular to the roof seams, the metal standing seams, and the modules, the long side of the module, are perpendicular to the rails. So they, what we call portrait orientation. And if you're looking at that roof. Here's a commercial system. This is a multi-megawatt, thousands and thousands of solar panels on this eventually. And you can just look at those rails. Just think about that, the amount of work needed to put those rails on. They all have to be measured, snapped, spaced properly, attached. And then after that's done, you start putting the solar panels on. One thing that I put a red circle just to notice that you can see those rails sticking out. And the rails have slots on top. And then you see the tiny clamps that are holding that module on. Those, I mean, that's really the system. So the rails are sticking out, they're perpendicular to the module. The clamps are attached to that. They can slide along the top of that rail. And that's what gives them the adjustability to tighten up against the module. So kind of keep that picture in your mind. Now let's go to a railless system. So this is a direct attach or railless. We use those terms interchangeably. So the clamp on the module is directly attached to this metal roof, in this case, standing seam. You can see that on the left. So there's no rails, and we'll get into this, but the actual, in a lot of cases, these direct attach systems, you attach the clamps on the fly as you install. So you don't have that first step I was talking about. Now, if you look at that circle again, it looks familiar. So those standing seams are the rails, and there's plenty of them. So those are acting in the same way. The clamps can slide up and down those seams or rails, and it acts in the same way. And that's really the basis of a direct attach railless system, why you really don't need to have the rails in. The seams become the rails. Or with exposed fasten roofs, the trapezoidal shape, the profile of the ribs or the corrugated ribs become that rail. So here's now a railless system. This is a commercial system as well. So you can see the individual clamps that go directly to the roof. There's no rails there. What's interesting about this is that this is in a high wind force situation. This is maybe in a windy area or high altitude or high building height. So you had to have six attachments per module to be compliant with codes. And you can see, obviously, the ones in the middle, they're shared, but every module is held down by 6 points. So if I had a rail system, I'd have to add another rail on every module. But with a railless, using the standing seam as your rails, they're there already. And I'm sorry, I'm sort of behind with the words. My clicking skills aren't the best. Here's another example of a railless system, direct attach. This is on an exposed fasten, a trapezoidal roof. Same thing. This is in a high wind area, so they're mandating that we have 6 attachments per solar panel. And you can see that there are plenty of the ribs are there. There's plenty of those ribs, those trapezoidal shapes to do the job.
Mark, the other thing that happens there on when you got the extra attachments in those high wind areas, it's also strengthening the roof and preventing the seam from unzipping.
Yeah. Well, in the case of standing seam, the clamps actually help keep the roof keep the roof itself, the roof panels onto the purlins attached to the roof, to the building itself. That's another topic.
Yes, yes. Just want to
But
mention that.
here's the mother of all roof solar projects. This is who's the headquarters? This is Apple's headquarters. Besides, this is direct attach, railless. There's no rails on this system. So besides the solar panels, there's also fall protection, service walkways, all using attachments, direct attachments to the roof. So all in all, there's over 100,000 points of attachment without any penetrations and no ballast anywhere, no warranty violation. And then now, Shelley, you're going to add some color to this regarding the challenge.
Yeah, this became a pretty complicated project, seeing that they wanted a round donut building and you've got square or rectangular modules you're putting on the top of it, and you want it to appear circular. You want it to appear round. As you could see there, they did a really good job with it. But that was a challenge to everybody involved in designing this building. And this, because they had the metal roof and they used the standing seam metal roof, it allowed them to use the direct attach and to adjust the seams in between, or Mark, help. The gaps. Thank you. The gaps. That allowed them to then widen the gap as they went out. And as you could see, looking at that, you don't see those gaps. When you get up close, you can see them, but from a distance, you can't see them. And it was definitely a design project. This became a big, it's a case study for architects to look at and learn from.
Much more difficult with rails.
But doing it with rails would have been very complicated. So
cool.
Go ahead.
All right, thanks. So here's really a direct attach clamp, a close-up of it. It's made up of an overhead clamp, which is pretty common, then a stem down the middle, the standoff, and then a base. There's a base down there. One thing looking at products, there's various ones out there. One feature that some have is that that bottom piece acts as a bonding and grounding element. So those two modules, the frames, which have to be grounded, all the frames on a system have to be bonded to ground to meet electric code. So that achieves that without having to add wires to it. So that's a good feature that some of these have to be able to do that. Here's a more close-up view of a clamp, and it's really a two-piece. Most of these are two pieces, where you have from that disc up is really the clamp, and that's the direct attach system. That's the railless system. And then below it are the clamps, and those could be most any roof clamps that attach to metal roofs, whether they're standing seam roofs or exposed fasten roofs. These, that's from this disc down is basically the the current technology in clamps that's been out there. So it's really a marriage of the clamp and this technology for clamping to the roof in one piece. So to further this point with a standing seam, there are all kinds of, as most people know, all kinds of different products out there, different roofs, different types of seams. Some are snap lock, some are seamed, mechanically seamed. So basically, you need to find the right clamp to fit the right roof to then attach your clamp, your direct attach PV system to that. They're out there. Here's just a view of a module with a direct attach system. The circled in the back, you can barely see them. Those are the mid clamps. So those are shared between two modules, and they're also, depending on what you get, it could be bonded together. One feature of a direct attach, since you don't have a rail, it's lower profile. There are advantages to that. Lower profile systems have less wind forces. There's less material, as we'll talk about. So, you know, there's advantages to having lower profile. And generally the direct attach, the railless systems are lower profile than a rail-based system. So talking about that clearance, one concern is airflow. Is there enough airflow to keep the temperature down so that you don't start losing efficiency in your module, which happens especially on hot days anyway. And if you talk to a solar panel manufacturer, they say, yeah, more is better. You know, we want it 10 feet off the roof, which is, you know, really unreasonable, and it's not needed. I mean, research shows, and I'll show a study in a second, that once the sweet spot is 4 inches, around the 4-inch neighborhood, once you're kind of past that you get negligible effects of height. So yeah, you don't want them a ½ inch off the roof, but when you're in that 4 neighborhood, there's enough airflow to work properly. And as I said, the higher modules are off that roof, the more wind forces. So you have to take more care, more engineering is involved in attaching them properly and keep them on the roof. And generally, like I said, the direct attach system, they're in that 4-inch neighborhood, which is adequate. Here is a research paper. And I'm not going to explain it, but basically if you look at that chart, the temperature is on the y-axis, and the individual lines is that gap. And as that gap increases, if you're beyond even a few inches, they start getting tighter together. So the negligible impact as you go above a few inches does reduce. To further, you know, our point of that. Here's, just to keep on talking about this height, here's a typical direct attach on a standing seam roof. The standing seam can be 1.5 inches to 3 inches. The clamp, and then above that clamp is the module. The module sits on that basically, and there's an overhead clamp on it, but that stack up is where you get sort of in that 4-inch neighborhood at the minimum. It's usually more than that. All right, there we go. So exposed fasteners, we've been talking about standing seam roofs. Exposed fasteners, there are brackets as well that provide, you know, that the proper stack up, and you can, as you can see in the bottom right picture, you can put a direct attach clamping system to these brackets, and that work effectively. The things that you have to watch out for, you have to make sure that the product that you get is sealed properly, and that's not an easy task. You know, you have to have a seal. In this case, there's a seal of the bracket itself, and then the screw itself has its own seal to ensure that. Products get tested to an ASTM test that you should look in. That should be, you look into, that's being done on the product that it works, that you're specifying. And as well, there are some screws that are drilling point screws that just really drill a hole, and then you only get really one thread to prevent pullout, whereas some screws are self-piercing, which push in, kind of penetrate in and create a tunnel. Excuse me. And then that tunnel actually will provide more thread so that you have a higher pullout resistance. So it's a improved, you know, so piercing screws are better than self-drilling screws in these instances, because these are only attached to the sheet itself, not to the structure. Here's a universal one. Sometimes you can't find a specific bracket. You know, there's a lot of different trapezoidal shapes out there. There's examples of these that are fully adjustable, not only from the trapezoid point of view, but can kind of go up and down to help improve the aesthetics of the solar system in the end. And you can just put a direct attach system to the top of that as well. The same thing goes, you have to look for the right product that has the right testing done and the right performance. The same, I don't want to dwell on it, but here's a corrugated roof product. The same, there's products for that as well to do direct attach on corrugated roofs. So another aspect of another sort of hit surprise bonus with low profile systems is it naturally prevents animals. So these are rail-based systems, and you have birds, you have squirrels, chipmunks, and of course raccoons living under these that can chew up wires and just make things dirty. And so naturally lower profile systems tend to be better at that. So before I jump into this, I'm gonna switch over to Shelley to talk about the importance of identifying the right roof for the product.
So many of the, I get a lot of calls from architects, even contractors who are asking, and our tech support, how do I know what clamp to use? How do you, they're wondering how can they figure out if this roof has been there, it's been there for years. We don't know what type it is. And we're looking to put a solar system on the roof. The best way to do this is use a tape measure, and you want to get the height, and you want to get the end of it so you can see the profile of the seam, and take a picture. That picture is worth more than you can realize. The various companies are able to look at that. You want to know the width of it. You want to know the height of it. We want to see the end profile. And then also, if you go ahead and you could draw, if you're not able to get a picture, draw a picture of it for us, for the manufacturer, and they'll be able to help you choose the clamp that will help, because the clamp is separate from the direct attach, and you need to make sure you're choosing the right attachment method. Back to you, Mark.
Thanks, Shelley. All right, so let's talk about the basic benefits, the advantages of having a railless system on metal roofs. The top four, I'll get into, Lord, but obviously material, you don't have rails, that's a lot less material, freight from that, handling logistics, and then we believe, and the premise is that there's a lot less labor costs as well, and we'll talk about that. As well, there's less weight on the roof, so it's safer for the roof. We'll get into this as well, but there's actually an increased distribution of load. So that dead weight and snow loads and wind loads are distributed more evenly over the roof than with a rail-based system. And because it's faster on and off the job, these tend to be lower profile, so they're stronger for wind forces generally. And as I said, you have a natural critter guard as well. All right, so I'm going to show a quick video of the basics of the tricks of installing this to show the benefits on a labor perspective. Let me see if I can get it. So putting a clamp on, what you do is you snap a line and put the clamps along the front row. So these are for systems that you can do this on the fly. So you put the first module in. This is high speed, and I'm trying to keep up with it. But the only ones you have to measure is that first row on your eave. From then on, the rest go on using the module as a jig. So that clamp is put on as that module is laid in place, not before. So there's no measuring. So you're not up there putting down rails. And then these things are adjusted and then tightened down. I'll show you another quick video, a quick perspective of this. Hold on. So here we go. So that's sliding in place. It's a little fast, but on the fly, the clamp is going in, and that's the beauty of being able to do it with direct attach, and you can attach it on the fly. That's where your time saving is. So let me do a quick cost comparison. And we did this analysis. We tried our hardest to get the best, the most accurate pricing, and we use a generic system of comparing rail versus railless. But of course, every project is different. Every project cost is different. So this is, we think, a good example. But there's a disclaimer. So this system is 150 modules, and I'll show you that. So basically comparing using rail, and it'll be portrait orientation, which I talked about, versus a railless system, which will be landscape, and I'll show you that. So here's the rail-based system. The rails didn't come out that well in this image, but they go across all the way across. So there's 6 rows of 25 columns, 150. You can see there's 2 rails per every row of modules. Here's the direct attach system, the railless. These are now in landscape orientation, but again, the seams are the rails. So the modules are still perpendicular to their seams because they're perpendicular to the rails. It's 10 rows now by 15, but it's the same footprint, basically. And you can see the yellow dots, those are the clamps from the direct attach, and those are directly attached to those roof seams, which are the rails. So from a labor perspective, our estimate is that you'd have 96 man hours to install this. And this is the basics of the installation, doesn't get into electrical stuff, versus 67 man hours to lay them in, connect them, attach them, and connect the basic wires. So looking at the bill of material, you can just look at the bill of material, what a difference the bill of material is, a lot less product. And obviously this is where also you get some serious cost savings because there are no rails. So it's close to half the cost of materials. This doesn't count modules or inverters or anything else. This is just comparing the attachment system. So all in, the summary of it is, from a material perspective, you could say 40-ish%. Labor is 30-ish, we believe. And shipping cost is extraordinary. I mean, it's not a big ticket item, but it's still a big cost savings on a percentage level. And then so all in, you could be upwards into the 40% range of cost savings for that part of the installation. And other factors, and the big one is weight. The weight savings, you have 85% weight savings by not doing rails, basically. And you can see that. Also, and I'll show that in a second more, is that there's more points of attachment actually with a railless system. And so you have higher distribution of loads. And the footprint is basically the same. We'll get into that a little bit as well. So a picture is worth 1,000 words. I usually say that wrong, but I said it right. Here's a 250 kilowatts of rail for a rail-based system. This is actually a project I was involved with years ago that was going from Massachusetts to California on this truck, 250 kilowatts. And now this is 250 kilowatts of a direct attach system.
In a short bed truck.
Short bed truck. You could put it in your car.
Put it in my car.
So now I'm going to get into sort of the system differences. We're going to first really show what rails really are there for and how seams can do the same job. And then we'll talk about into detail wire management and installation methods, and then module level power electronics, which are optimizers and micro inverters, and how those all fit in and how you don't need rails for those. So rails do not provide structural integrity to the system. They don't. Once they're installed, of course, they have to be strong enough, but that's not why they're there. They're there because they interface the PV modules to the ribs and seams of a metal roof, which is purely geometry. And so the rails attach to the proper place of the modules, and then they attach the roof. But as we'll get into this, your ribs or standing seams can really act in the same way. One big thing, which I have mentioned, is that a shift in thinking is going away from a portrait orientation, because now the rails are perpendicular to the seams and the modules are perpendicular to the rails. But now with a railless, the modules are perpendicular to the rails because the rails are the seams. So this is to demonstrate the point I was saying about more or less touching points. So this is a rail-based system. So every module is clamped to that rail in the same way. So that's clamped down to that rail. So every edge of every module is clamped down. But the rails can now touch the roof however they want. So generally they're 4 foot, 5 foot, 6 foot on center. So you see 3 or 4 modules and you only see right here, you see on this edge anyway, 2 clamping points to the roof. They're only attached twice to the roof. But yet if you look above it, you have 3 points of attachment from the modules to the rail. Now let's look at the same thing with a railless system. the clamping points to the modules are the same as what attaches to the roof. So as you can see, you have more attachment points to the roof itself. So load is transferred, just distributed more across that roof, which is better for the roof. Big point. Just to show this again, if you're not getting tired of it, this is a rail-based, which is portrait orientation. You can see the rails below it, and you can see the seams running vertically down the roof, as if you're looking right at a residential roof. And a railless system would be in landscape and using their seams as the rails to connect. This is not totally set in stone. You can see rail systems that are landscape to the roof, and you can see railless systems that are portrait as well, because it all gets into where the locations of the seams are and where you want to touch the solar panels themselves. And we'll get into that now. So solar modules all have specified loading zones. They're very similar across the board. They all differ a little bit. So this shows, for low snow in the areas, I can do the yellow. I can attach anywhere on the, anywhere on the green. And then for the higher snow areas in the green, and then for lower snow areas would be the yellow. And this is just one example. So I have to attach those modules to either the green or the yellow. I cannot attach to the red, and as far as primary attachments. Maybe you do secondary attachments to make it even stronger, and you put those in the center, but your primary attachments have to be in these green or yellow zones. And in this case, these are 33 to 66 inches apart. But now roof rib spacing can vary. So for a standing seam roof, they can be 12 to 24, and there's some basic sizes that are out there, like 18 inch, 16 inch, I guess. 12 to 24 inches is very common, but that's what you have to match up with. And then on exposed fasten roofs, it is tighter. So you have, for instance, a trapezoidal roof, which is more like 6 to 12 inches. And then corrugated roof would be, a standard is 2 3/4 inches. So there's a lot more of those to be able to line up. So that's the puzzle. The puzzle is, and a hesitancy is how do I line all that stuff up? But it's really a simple geometry problem. And here's a real case. This is a real project lined up. And these are 42-inch spaced seams, which is on the high side. So generally, the tighter the seams are, or the ribs are, the easier it is to make all this work. So this worked, but we had to have every 2 modules, there had to be a 10-inch gap in this case, because you're matching up the loading zones on the modules with the ribs. So you have that in, but those are actually good. There's benefits to having aisles. And so operations and maintenance, known as O&M, first of all, installing is easier if you have some gaps in there to be able to walk through. And then long-term, just doing the repairs and maintenance, it does add benefits. So there's benefits to that. I definitely understand people want to put them as tight as possible, but there's definitely benefits to this. But in this case, we had to do that. But if I shove all those modules together, I could not add another module to that system. So that's just an example of that. I think I better start speeding up too. So here's a common one. And I know this solar developer, actually, he makes sure that there are these aisles. He designs this specifically for this. So every other module, there's an aisle, so you can get access to all the wiring, wire management, and every module can be accessed without having to step on a module, which is not good. So it's not uncommon to see people, if you have the space, to put aisles periodically like this for O&M, and just for it makes a quicker installation as well. Here's some examples of FedEx building. This is probably on the bigger side. This is a 7% space loss from correction gaps for direct attach. In Germany, less. This one is much less. This is direct attach, and you really can't see much difference in the gaps if you look at it, unless you look closely at it. So in most cases, you can put as much as you want in where you want them, but you have to pay attention to that part of the design, which is a new thing with a direct attach on metal roofs. All right, I better speed up, I think. So let's get into some of the details of wire management. So some of the basics is that a module has a positive and negative power conductor. 2 power conductors that come out of every module, and I'll use that term positive and negative, meaning it's basically a DC power structure. So the module creates DC power, and it comes out of those two power conductors. So what happens in a very common type of inverter, which converts DC to AC, is a string inverter. So modules are put together in groups, and that group can be 10, 12, 16 or more together, and they're connected in series. But then at the end of them, you still have one plus and one minus, which then has to be routed to that string inverter, shown in that red and black wires. That's the trick. You have to build these strings, interconnect these strings as you're building a string, the modules, laying them in place, and then you end up with an end of a string that you have to then put a jumper on it and jump that all the way back to the inverter. So that's a string. And I'll use that, and I'll use plus and minus throughout my presentation. So the key element is that the wires cannot sit on the roof long term. During installation you can, but when it's all said and done, the wires all have to be tucked up, and it's very common to tuck them up into the module frame itself. That's very common, as well as clipping them to various things. Some direct attach systems have slots to wire tie bundles to. There's other methods. There's wire trays that you can put bundled wires in, the jumpers that I'm talking about. But it's key. An important rule is wires cannot lay on the roof. And I'll get into, there's two important points that I'll try to drive home in this area. One is module prep. So in order to really take advantage of the time savings of installing a railless system without the rails, module prep is really important. It's important to get wires tied up so that when you're up on the roof, they're ready to go. So just picture at the right, they're just installing that module in, and he's connecting the two conductors together as you're putting it together. He doesn't have to worry about where the rail is, putting it on a rail. And on the picture on the left shows what it takes to do that. So all that work is done off the roof, on the ground, or maybe in a staging area, but it's like an assembly line where you throw a module on and you just clip it up, and they're all done in the same way so it's really like a machine that's doing this. And the better you do there, the less time you're on the roof. So that's very key with direct attached systems, is to do that prep and to design that well. Here's clips, and I put this in here because there's just clips, all kinds of clips out on the marketplace now that can do very specific things. So whatever your need is, you could have a multi-lumen, single lumen, whatever the need is to attach, where you're attaching these wires to the frame or whatever, they're out there. So, all right, so let me show you. So now we're getting into the subarray level. This is a solar array, and the strings, you can see the strings have the pluses and the minuses where that string ends. So the key is to getting the jumping from the modules that have the end of a string. They may have a minus conductor that has to be routed to the inverter. The one on the left is a typical residential system. You may have a few strings. The one on the right, there's a lot more. It's much more complicated. There's a lot of pluses and minuses in there. There's a lot of string ends that have to then be brought down to that home run. Here's what a home run looks like. So the modules, the jumpers are brought from the string ends out to the outside of the module, the subarray, and then they're put into a wire basket or some kind of cover tray. And then those are then routed to your inverter. Whether you're rail or railless, that's the same. Those home runs are basically the same because those are outside of the modules. Again, this other picture is a combiner box, which combines wires to reduce the bundle size. It can only be used with a central inverter, which are not as common anymore. String inverters, every plus and minus has to be routed individually to an inverter for it to work. So the other key point, so I said one key point was module prep. The other key point is strategic string design. So you want to, the one picture on the left, they're just in series. You lay down a string and the next one follows, and you just go up back and forth, and the pluses and minuses are everywhere. You then have to, as you build, you have to put jumpers on there that have to be routed down to your home run. The one on the right, there was a little thinking done. And so that thinking, they did each string so that the pluses and minuses of those string ends are towards the bottom, so that there's just less jumpers, less work for that. And you can see, as you can imagine, there's a big difference between the right and the left one, which is very important. That's another very important aspect of, I can't say enough about it, of using a railless design, and this work can be done at your desk. This is before you even get up on the roof. This is already completed the design for this. And the key is now, how do you route those to the home run? So I'll show another one, and I'm going to talk about this one a little bit later. This is, to me, the ultimate idea, where they actually created an asymmetrical aisle down the middle, not even down the middle, but this is because they had 16 strings of 16 modules. So they were able, I just modeled this on a spreadsheet, but you're able to then say, all my string ends are at that aisle. So you don't have to do any kind of working with string ends in the middle of the subarray. You can build this system, actually, then go in after and run your run your jumpers to your home run by just walking along those aisles and connecting them into your string ends are like right there. You can just reach under and do it. This is ideal. You don't get that, but this is just an example of how ideal it can be. So for residential, it's not that big a deal. You get a couple strings. It's not a huge effort then, as you're building, is to tie up the jumpers as you move. You don't need rails. You can still, it's easy to clip those on, because it's just a few of those. And then you'd have conduit that is your home run, is your conduit, and that goes into the house, or where on the side of the house where your inverter is. Simpler. So now when we get into the commercial side, it gets much more difficult. So you may have subarrays that are sprinkled around a roof that are 100, 150 modules. That's a lot of strings and a lot of then jumpers that's needed to run those from those string ends down to your home run. You can look at it. One common method is, I call a direct method, where as they're laying, they're connecting in putting the module in, as we saw with the video. And then if you see a string end, you plug the jumper in, and then as you're building, you just keep that jumper off the roof. This is where you can see the difference between the strategic design on the right, and there's just less of that work on the direct side. Going through these, I already talking. I'm not a good clicker. So this just shows before the modules are put in. This is direct attached. So those jumpers are actually laid on the roof ahead of time, and then as they build, they're connecting them to the string ends, and then they're picking them up, and then the top part is your home run. So it's definitely doable. It's still a cost savings, but what I'm saying is designing your strings well saves a lot of time in this arena. And now I'm going to show this again, the strategic string design. You can see again how by putting those designing the string ends to be there when you're laying the modules, it's just such an easy task to do the wiring. You do not need rails. It's, and by the way, I would, even if I used rails, you benefit from doing a strategic string design. I think with rails, people are just, it's just easy not to worry about it, but you benefit from that. And I'll jump in here. I know that we're now joined by Dustin Haddock. He's going to help answer Q&A. So you can actually open the Q&A box, see if there's any questions. No, okay. All right, cool. Welcome, Dustin. He's VP of R&D, by the way, at S5. So another method that I talk about is using what I call a trunk method, where there's actually wire management trays underneath that, in between two seams into that subarray. So say there's cases like, okay, obviously this is ideal. You may have cases where you do need to have string ends that are in the middle of an array. You can't avoid it because your string size just don't match up with what you're trying to do. So you save time by having that wire tray under there, because now you just have to worry about clipping up the wires till you get to that wire tray. So now instead of going down to the home run, they go over to that thick red line, which is the tray. And then once they're in the tray, they're just there. You don't have to worry about them. A lot less work. And the picture on the right is actually a rail-based system. This is the same multi-megawatt system I talked about, rail-based, and they use that technique. So on the right, you can see a wire basket, a wire tray that they use. So the string end you see in the foreground, they've zip tied on the rail, but only to that point where the wire tray is. And then once they're in the wire tray, they don't have to worry about it. So if they save time by doing it, it's definitely a time saver to do this method if you need to with a railless system. A version of this, which is really, I like this version as well, is making the gaps that are needed, just maybe 12 inches here and there, to then be able to put the wire tray on the outside of the tray or tucked in. So that way you can do, you bring those wires out as you're building, but then you can do that wire tray after, and then you have less, it's easier to access that, a little bit easier for long-term O&M. All right, so I'm going to get away from wire management and get into steep. So one nuance of steep slope with rail versus railless is the technique itself. And it's all about getting footholds. And the technique that we are promoting that is a good way with direct attach is to build column by column. And I'll show you that. And it's similar to what we showed in that little video. So yes, at the bottom along the eave, you put your direct attach clamps in, your railless clamps in you snap a string and get those lined up. But then after that, you can build column by column. So you put the module in and the clamps go in on the fly. And you just repeat, you put the module in, just as we saw in that video, and the clamps go in on the fly, using the module as the jig. The benefit of this, I should have mentioned this, is that if you have scaffolding, if you did a whole row across, you'd be moving the scaffolding all the time, and then you'd have to walk over the row to the next one. By doing this, you could have scaffolding just next to it, next to that column as you're building, and all you have to do is move up and down that scaffold, get this row done, then move your scaffolding and start this with a column and just kind of walk up that column. That's the really efficient way to build on a steep slope roof, because you need to be tied off, you need safety harnesses, and you need a scaffolding to be able to be safe. It keeps on going and going, column by column. No measurements, no rails. Here's a couple of, what's it called? Endorsement. Testimonials, sorry. So this is one from somebody who's been using a railless system for more than a decade. He's based in Colorado. He's given us advice as to some of the nuances of these techniques. And once he started using a railless system, he would never go back to a railless system. And then another one, this is in New Zealand. This is the biggest railless system at the time installed in New Zealand. The same thing. Not only from this did they love using direct attach, not having those rails, but from a timing perspective, they were installing modules at less than 1.5 minutes a module.
And that was a first-time crew.
That was a first-time crew in New Zealand using a railless system. And you can see that column, you can see the clamps those in between the modules. So here's sort of that in as it works. So this ladder is a scaffolding. It's laid up safely. The builders are all harnessed in with fall protection. So they basically walk up, work up that column, and then you move over. Then you work up another column. Again, so I can't stress this enough. That module prep ahead of time is key. If you clip up those wires and just have every one is repeatable. It's like an assembly line down there. So if that pigtail where the conductor end is right where you need it, as you're sliding in loading that module in to the clamp, you just clip that in and you're done. So there's a lot less time if you do that work ahead of time. Not only designing it, how do we want it? Where do we want those pigtails? But then reproducing it 100% on the ground before you put it up on the roof. Very important. Again. So one point is, and people, if you're really trying to compare them, the real life, using a rail-based system is also very tough. I mean, steep slope installations are tough no matter what you're doing. They're not easy. You have to do them well. So these are just examples of kind of hilarious extreme cases, but it's driving home a point that it's not easy. So even with a railless system, there's work and you have to lean and stretch. But with the rail system, you would do the same. And just because you can, the fallback is to use the rails as stepping, as scaffolding, which really, you can argue is not really the proper way to go anyway. But it's just easy to do that. But that's not a reason to do that. And
It's an expensive way to-
right, and Dustin has said this to me before, if you're putting rails up there only because of a one-time scaffolding use during installation, it's very expensive scaffolding that you can't take back and use again. And I would say the same thing with wire management. If you're using rail, the only reason you want rails is for wire management, that's expensive wire management. All right, so getting back to a railless installation, you can just see, he's leaning over, they're doing that column next to it, and then they would slide over and start another column. The module is lowered into place and attached. As I said, it's not incredibly easy. The installers are stretching, but even if you had a rail-based system, you wouldn't, there's some difficulties there. It's not easy either way. It's kind of scary being up on the roof. I've been on enough roofs. It's scary up there. Just more pictures of that. And it's so key, as you can see, if those pigtails are ready to go, the conductor ends, and you're just snapping those, you're just plugging those in, it just makes, and you don't have to worry about clipping anything up on the roof. That's key to time savings. I think I've said it too many times. As well out there, this is specific to standing seam roofs. There's scaffolding out there and fall protection that uses that same technique, squeezes the seam, so it's not penetrating the roof. You don't have to do sophisticated things. It's pretty simple. And the picture in the center actually is one that's being used to put solar in. So that scaffolding can just be moved around pretty easily, up and down. All right, so let's get into module level power electronics. So basically there's now three types of module level power electronics. You have microinverters, which every module can convert from DC to AC, optimizers, which are DC, which just control better the electricity coming out of every module. So you make everything more efficient and make more power of your system. Another one is called a rapid shutdown device, which is used to be in compliance with rapid shutdown code. That's rules that are now in effect. So these things have to be put somewhere. And I would say in most cases, putting them on the module is the better way to go. And I would say that especially with optimizers and rapid shutdown, those are DC. So when this picture, you do this on the ground in your prep, it's very little extra prep. You put the module on the frame, the optimizer on the frame, you plug it in, you clip up the wires to the frame in the same way, and you end up with the two pigtails the same way as you did before without that optimizer there. So all that work is done on the ground, and it's very little extra time work. That's a no-brainer. I don't see any reason why you'd want to put a optimizer on the roof ahead of time, but people do it, but I think in a lot of cases, it's just better done on the module. And if you really want to take advantage of the time savings of not having a rail-based system, that's really a good way to go. Again, I'm showing this picture of clips. You can solve all these problems with the specific clip you want to get to clip up, all the extra wires from an optimizer and from the module itself. So it's all a tight, neat, tight package that can just go up on the roof and be installed quickly. You can, obviously these things can be put on the roof, and there are products out there, the same clamps you use to attach, your system, your direct attach system to the roof can be used to attach module level power electronics as well. So it can be done, and companies support that as well who make this product. Here's another example. This is corrugated roof, using a bracket for that and putting the optimizer, or I think that's an optimizer, on the roof directly. And then as you put the module in place, then you have to clip it. You have to then plug it in. But in most cases, I really believe that it's good if you can to do it on the frame ahead of time, on the ground, part of your module prep. Here's another, this is a trapezoidal roof, that microinverters there on the frame ahead of time. So I say optimizers and rapid shutdown devices are a no-brainer to do. Microinverters are a little different. Microinverters, they're AC. So you plug two plugs into the microinverter from the module, and then one single AC power trunk, a big thick cable, interconnects all your microinverters. So you really can't do that as part of your prep on the ground. What you can do is you can still install the microinverter on the module, lay the cable ahead on the roof in its place. And then as you're putting the modules in, you're still saving a lot of time. You're clipping those, you're plugging the AC trunk in because the microinverter is already in place. And then you're just clipping up that frame, clipping up the trunk to the module frame. The picture on the right, the bottom right is, oh my God, I'm running out of time, aren't I? Geez, so that cable is clipped up, and it's very easy to do that. There's specialty clips for that. So that can be easily done as well. It's a little different than optimizers. All right, so I'll end my part by as well. There's balance of systems. You have home runs. You have combiner boxes, and those all can be connected with the same clamps you use on a metal roof. So it's easy to put solar on a metal roof. Walkways as well. So I'm going to let Shelley wrap it up if she has a minute.
Okay, so now that you've completed the course, you're going to be able to, you now know why a metal roof is a perfect solar platform. You can define the advantages of rail-less solar PV mounting systems. You should understand how solar on metal roofs prove to be the most economical and the most eco-friendly. You should now know best practices for design and deployment of wire management, and describe best practices for installation techniques and other balance of system components. So this concludes the AIA portion of the Continuing Education Systems Program and the NABCEP portion. If you want to start entering your questions, feel free to do that. We do want to thank you for being here and joining us. And we did want to tell you a little bit about S5.
It's just a couple of slides. We got to end it, I think, but.
No,
You're okay. You're okay.
Oh, it is all right. Okay. Sorry.
So we want to, tell you why S5 makes a difference. First of all, our CEO and founder, who developed the first clamp that was used on the standing seam roofs. And we are, he is a renowned industry expert. He is a director of the Metal Roof Advisory Group. He is a forensic expert. He's an author, lecturer, and a building envelope scientist. He's always working to further the industry, whether, it's not necessarily just about the attachments to the roof, but it's furthering the metal roof industry. And he believes in engineering and doing things the right way. So these are things that we can list that, we are proud of. Everything that we do, we are, we engineer, we test, and we, our certifications are with UL, FM, Intertech, ICC. Our factory is ISO 9001. And, our employees and, everybody is participating in the various organizations. So here, this is an example. We put all our load testing on our website. So everything is available. We've tested over 3,000 panels and over 500 roof profiles. And you can get the engineering reports. So all the load test data to engineer your project. I mentioned that, we are a certified manufacturing facility, and we are regularly, and they'll visit without notification to maintain that certified manufacturing and our certified material. These are the facilities, and this is why we're tested, trusted, engineered, and we help create these industry standards. We are a market leader, and these are the testing, the labs, the certifications. This is who we're working with and who approves us. And then, not just the company, but the various company employees like myself, Mark, Dustin, who are all here. We all are members of various organizations, and we contribute to all of this. And that's really what, makes us better at what we're doing. And we work with all of these manufacturers, and we are, approved or recommended by these manufacturers, and many of them recommend us as part of their roofing systems.
So we
Next.
actually have a question that's come through, and I think it's something that might be of interest for everyone that's still listening to hear. Are there any fire safety performance benefits with railless solar installation compared to rail installation systems?
Hey guys,
Dustin?
I wanted to grab that one live. I'm sharing a space with one guy, so if he can mute his computer, we won't get that echo. Does everybody hear me all right?
Yep.
So Vince, thanks for the question. Just so everybody knows, Vince worked with us and really kind of helped lead the charge with the non-combustible task group within UL 2703, to which we were able to prove via testing some exemptions within the building code for having to have a fire classification in assembly with PV modules. So when you're attaching to a non-combustible structure, you're exempted from that standard to have further testing to prove whether you're class A, B, or C. It's just class A. But the question specifically, is there a difference between direct attach and a rail-based system as it relates to fire ratings? And per that standard, no, there's not. That's if you're mounting to a non-combustible structure such as metal, you don't need to do any further testing. However, based on the testing that we did, I mean, we ran those tests in such a way that it created a convective air plenum. So when you're doing a direct attached system, you're a little bit lower to the roof surface, and you're minimizing that convective air plenum that could help fuel fire, light the back sheet of the module or something like that. When we ran those tests, we actually lifted the modules up higher than you would normally for a direct attached system to create the most optimal airflow situation. So if something bad was going to happen, we'd be able to, record it via testing. So I hope that answers that question. Per the standard, it doesn't matter direct attach or rail. In practice, if there's a fire going out there, if that convective air plenum is somewhat reduced, it's going to do a little bit better for you.
Do we have any other questions from any attendees? We'd be happy to answer them for you. Okay.
Here's a new one. Oh, thanks. Okay.
Okay, well, it looks like we are all set. It looks like we don't have any additional questions.
Is that good or bad?
Huh?
Is that good or bad?
That is a good thing. That is a very good thing.
You may have answered all their questions during the
Yeah.
course.
Exactly. So I think we will wrap it up for today. Does anyone have any final comments?
Just want to say thank you for having us and look forward to seeing everybody at MetalCon. And definitely sign up for those, if you're architectural, sign up for the architects, experience, and then the solar center. Anybody that's in the solar industry or thinking about it, definitely check out the solar center as well.
Hey, thanks everybody for your time. Thank you for programming in, and I hope you learned a lot about what we're trying to teach, and that Metal Roofing is the greatest solar platform out there. So appreciate it.
Absolutely. Well, we can't thank everyone enough for joining us today. Thank you everyone for listening live, and for everyone who will be watching this later on demand. As promised, we do have your AIA HSW credits waiting. All you need to do is fill out the survey that follows this program immediately. You'll be receiving that via email. If you have any questions, comments, or concerns moving forward, you can always email me directly. I'm at kaylin@metalcon.com, or you can email us at info@metalcon.com. We look forward to seeing you soon, and we hope to have you at MetalCon next in October, and we hope to see you in 2 weeks at our next MetalCon Live. Thanks, everybody. Have a great day. Bye.
Bye.